Alrighty, folks. So we are starting in the guided practice. It's not a lot of space on these problems, which I don't love, but we're going to try to make the most of the space we have. Now on number 1, we've got some differences because this one has both, multiplication and division. Now the division only really affects the thing behind it. So I'm going to keep all the stuff to the left of the division sign. I'm going to change this to multiplication, so change, and then I'm going to flip this fraction. So I'm going to put the x squared minus x minus 20 on the top, and the 3x squared plus 2x on the bottom. And folks, I crossed off the original problem just because otherwise I have tried to use both fractions in the same problem. So cross it off, it's gone. We have changed it to be multiplying by the reciprocal. So this is kind of our starting setup. I'm going to trap that trinomial, trap that binomial, trap. All binomials and trinomials here, no monomials to mince up. So looking at the first fractions top, now that these are all joined by multiplication, we can put these fractions together. Multiply. So 3x squared minus 7x minus 6. There's no GCF. No GCF to take out. But there's an A value. Oh, everybody's best friend, the X method. Folks, are we feeling better about the X method since we used that with fake quadratics in the last unit? I really did feel like there was a big step up on the test, so I'm hoping that you find it a little bit easier. So first, we want factors of 3x squared, 1x and 3x. Factors of 6, let's do 3 and 2. So 1x times 2 is 2x. 3x times 3 is 9x. If we want that sum to be negative 7, who needs to be negative? The 9. So to get that 9 to be negative, we need that 3 to be negative. So the 1x gets paired with the negative 3, and the 3x gets paired with the 2. So x minus 3, 3x plus 2. Continuing on with the numerator of our big old fraction, x squared plus 4x. Can I factor that? GCF. Take out an x from both of those. And note that in between all this stuff I'm taking out, it's still all multiplication. What about x squared minus x minus 20? I'm looking for a product of negative 20 and a sum of negative x. Is that sum 0 or negative 1? It's negative 1. So sometimes students go, well, there's no coefficient, so that's 0, right? Having a x is the same as having 1x. So that is a negative x. So product of negative 20. 1 and 20, no. 2 and 10, no. 3, can't divide 20 by 3. 4 and 5, it's looking good as long as who's negative? The 5. So x minus 5 and x plus 4. So negative 20 for the product and negative 1 for the sum. Look at all those factors. My gosh. So I wasn't kidding how factoring was going to become really important for this unit. Folks, I want you to try to factor all those denominators. 20 seconds. Ooh, fast. Product of negative 12, sum of 1, x plus 4, and x minus 3. So that will give me the product of negative 12 and a sum of positive 1. And then, can I factor x minus 3 any further? No. Nope. So x minus 3 continues. And then 3x squared plus 2x. Why don't I use the x method on this problem? Because there's a A GCF, it's kind of a sneaky one. Again, sometimes your GCF is a number, sometimes it's a variable, sometimes it's a number and a variable one. For this one, the only thing I can take out is just an x. And that leaves us with 3x plus 2. Oof! So all that factoring work, but now the fun part, where we get to cross out things that are the same. So we can take out an x minus 3 with an x minus 3. Hey, does it matter which one I take out, this one or this one? Nope, just as long as I'm only taking out one top with one bottom, because that's what equals 1. What else can we take out? 3x plus 2, 3x plus 2, x plus 4 over here, x plus 4 over there. Can I take out that x? Yeah, with that monomial x. Anything else? That's a no. So all we have left is that x minus 5, the x plus 4, both on the top, and then the x minus 3 on the bottom. So I'm just going to squeeze that in right here. X minus 5, x plus 4, over x minus 3. Notice how I'm keeping all that stuff trapped in the parentheses. Beautiful. And I think we'd agree that this looks way better than that 3 fraction nonsense that we started with. That's the goal in these problems, to get it down to one better looking, more simplified fraction. So folks, moving on to number 2. Trap, 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 trap. I trap all my stuff first so that I'm not looking at this going, I'd sure like to take that x squared out from that x squared. Can't do it. You cannot steal stuff from binomials or trinomials. So it has to be the entire parentheses term with the entire parentheses term. Before I get too excited about factoring, our operation is division. So we're going to have to keep the first fraction, change to multiplication, and flip that second fraction. So 3x minus 3 on the top, 2x squared minus 5x plus 2 on the bottom. Cross it off so you don't try to use it. And trap, 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 trap. So at the top of the first fraction, there's no GCF. We've got an value in front of the x squared, so this calls for the x method. Go ahead and try this one on your own. Just the x method on the top one. And you can continue if you're feeling factoring and confident. Ooh, this first one's kind of a tough one, folks. When I go to the x method, we say 3x, 2x, and we go, oh, huzzah! 3x and 2x gives me 5x. Why doesn't this actually work, though?
Because it doesn't give -3.
Perfect. It doesn't give me the right product number. So that's why, folks, it's always a good idea to check your product number after you have figured out the puzzle and gotten that middle term. Oftentimes, it's when you flip the signs that you'll notice it, but this one's kind of a doozy because we didn't have to flip the signs at all, and it doesn't end up giving me that right product number. So that's out and that's out. Flip those values, and we get 1x and 6x. So make the 1 negative, make this one negative, and that will give me the product of -3. What an evil little factoring problem. So then my factors would be 1x with the 3 and 2x with the -1. So x plus 3 and 2x minus 1. And then we move on to the other top. 3x minus 3. When I ask third block, can we factor that? They're like, no. But it's not no. How can we factor this one? we can take out a GCF of 3. So once again, in big letters, GCF. It would help if you guys could see it. There we go, GCF. So I can take a 3 out. And if you're like, yeah, but what if I don't? What if I don't take out my GCF? Because a lot of times with like the quadratic formula and stuff, it's like it doesn't actually matter if you take out that GCF. Here it matters because if I don't take out that 3, I might not be able to take 3x minus 3 out with something, though I might be able to take x minus 1 out with something. So we always want to factor fully because that's going to lead me to my most simplified fraction. Let's go ahead and move to our denominators. What am I going to do with 3x squared plus 9x? GCF. We can take a 3 out. What else can we take out? And x. So take a 3x out of both of those, and that leaves me with x plus 3. And then 2x squared minus 5x plus 2. Another x method. Lovely. So 1x and 2x. Let's do 2 and 1. So that 1x times 1 is 1x. 2x times 2 is 4x. And if I need the sum to be negative 5x, both of those turkeys have to be negative, and both of those numbers have to be negative. Ooh, I don't want to lose that minus sign in there. So x minus 2, 2x minus 1. X minus 2, 2x minus 1. Oof. So all that factoring, and we're all angry about it because we hate factoring, but now we get to cross off factors, and that's the fun part about this. So x plus 3 with x plus 3, goodbye, goodbye. 2x minus 1 with 2x minus 1, goodbye, goodbye. There is something else we can cross off. Anyone see what it is? The 3's. If you're like, no, Mrs. Cairo, because this one's 3x and that one's just 3. This 3x, though, is 3 times x. If I break that down into factored form, I can just ignore that x and cross off that 3 with that 3 directly. So careful that you know you can mince the monomials. So what we're left with is x minus 1 on the top. This sneaky little x is still left, and then x minus 2 on the bottom. So please write your answer in simplified factored form. X minus 1, trap in parentheses, and x times x minus 2. And again, it wouldn't be horrible to redistribute that, but it's considered better form if we leave it in factored form. So that's all good. Any questions? Any questions on that one with any of the X method stuff? Any of the factoring? Let's see. All right, folks. Number 3. Trap that binomial. Trap that other binomial. Monomial. I'm just going to show that, hey, this is already factored as 4 times x. 2x plus 3, trap. So factoring-wise, we've got multiplication, so I can join these fractions together. It's one big fraction times. How am I going to factor 4x squared minus 9? You could do the x method with a sum of 0, but 4 is a perfect square, and 9's a perfect square. Folks, this is difference of squares. So 2x plus 3, 2x minus 3. Perfect square factors of 4, 2 and 2. Perfect square factors of x squared, x and x. Perfect square factors of 9, 3 and 3. 1 gets a plus, 1 gets a minus. Moving right along to this other binomial. How am I going to factor that? 2x perfect, GCF of 2x. Now, I forget where I saw this. It may have been on one of the homework quizzes. When I take a 2x out, I'm taking it out by division. So 4x squared divided by 2x is 2x. What's negative 2x divided by 2x? Negative 1. Sometimes students are like, I take out a 2x and there's nothing left there. It is a negative 1, and we have to have that there because if I were to redistribute that 2 and that x, it would need to be equal to the same thing that we started with. So I have to have that negative 1 there. On the bottom, 4 times x and 2x plus 3. So what can I cross off? 2x plus 3 and 2x plus 3, goodbye. What else? An x, wonderful, and then a 2 from the 2 and the 4, which leave me with a 2 on the bottom. So then my final answer is going to be 2x minus 3, 2x minus 1, and 2. Folks, these problems get really messy. I prefer if you do a simple slash through your work. That way I can still tell what those factors were to make sure you have factored correctly in some way. So a simple slash, don't angrily scribble out unless you want to angrily scribble out up here. But a simple slash so I can still kind of sift through that work is helpful for me. So 2x minus 3, 2x minus 1, all over 2. Can I take a 2 out from that 2? No, and if you're like, but those are joined by multiplication, Mrs. Cairo. Yes, they are, but not that minus 3 that's throwing it off. If it's a binomial, you cannot take parts from it. That's our final answer. Hey, why aren't we going to do number 4? That's addition, and addition is significantly harder than multiplication. If you're like, don't say that, Mrs. Cairo, this was hard enough. Yes, there's lots of factoring involved, but the canceling part, not so bad. Addition takes it up a notch because of what we have to do with finding a common denominator. I want you to sidebar back to the notes for a moment. Because in times of trouble, when I can't remember what exactly I need to do with fractions, I always think about pizzas. And the easiest fractional pizzas I can think of. A half of a pizza and a half of a pizza. What is a half of a pizza plus a half of a pizza? One whole pizza. So it's like, all right, it equals 1. But how do I mathematically get it to be equal to 1? If I add the tops and add the bottoms, so going straight across like we did with multiplication, I get 2 over 4. Is a half plus a half a half? No, that doesn't make sense. So what are we going to do to make this work out mathematically? We only add the tops, which gives me 2, and then my denominator, the common denominator, stays the same. So 2 over 2 equals 1. So if you don't remember how to do fraction operations, it's always a good idea to look at some simple fractions and think about that pizza. If I have a half of a pizza, plus a fourth of a pizza, how much pizza do I have? If I move this slice over here, over to that wedge, how much pizza do I have here? 3/4. So again, it's not quite as friendly as 1/2, but we can still kind of visualize it. Or you can think about half of a dollar is 50 cents. A quarter of a dollar is 25 cents. So 50 cents plus 25 cents is 75 cents, or 0.75, which is 3/4. So I want you to consider this just sort of visually first so I can kind of explain what we will be doing tomorrow. Folks, why can't I just add the tops together here?
Because there's no common denominator.
There's not a common denominator because it's like, okay, I add the tops, but then which of these do I use? We have to choose which one we want to be the common denominator. And what we're going to find tomorrow is we're going to take the largest amount of each factor, or the largest amount here would just be 4. So I say, all right, can I make this 2 look like a 4? Yep, we could multiply it by 2. Now, I'm not the god of math. Maybe you are, I don't know. But can I just straight up multiply that denominator by 2 and say it's all good?
No, you have to multiply the top too.
We got to multiply the top by 2 as well. Folks, we have a special name for this item that I have boxed. It is called the creative form of 1. Or I think in calc they sometimes call it the clever form of 1. Creative form of 1. Because I'm multiplying 1/2 by 1. Is it still 1/2? Yeah, anything times 1 is just that thing. So when I multiply those together, going straight across. 1 times 2 is 2. 2 times 2 is 4. 2/4 is the same as 1/2. I have not changed the value of that fraction, but this has allowed me to add the tops, keep the common denominator, which will give me 3/4. This is a great skill that I like to remind students about for the ACT. If you can't remember how to do something complicated, see if you can remember how to do it with something basic. 1/2 plus 1/2, my easiest fractions that I encounter all the time when I'm baking and cooking. Same with a 1/4 of a cup. Actually, folks, if you struggle with fractional stuff, if you start cooking in large quantities and doubling and tripling recipes and start measuring stuff, you're going to find that your fraction skills go up exponentially. You may have to bring your calculator in the kitchen. I do not recommend using one of these in the kitchen. You'll get flour all over it. But you can always check yourself with those fraction rules. So what's nice is for something like this, oh boy, I can do 1 divided by 2 plus 1 divided by 4. Math, enter, enter. And I can see, yep, that's 3/4. But can I type in these fractions and simplify on these calculators? We cannot. So it's nice to review how things work with regular fractions before we get into the less regular fractions tomorrow. So this is what we will be getting into tomorrow. For the rest of class today, we are going to be working in the homework packet. So go ahead and take out those purple ones.